So I'll update it and we can try again. I'll switch on screen sharing to make it more interesting.
Sure. And yeah, Igor, thanks for the demo. That was interesting, at least for me.
Yeah, if you will have further questions, I could answer later.
Sure.
So like this.
Yeah, might work.
So let's start from scratch with a shorter introduction. So we are demonstrating the lock and mint token bridging from Solana blockchain to Unicity. And lock and mint means that there is a source contract which locks up tokens at the Solana blockchain, and it generates a log event which is captured by the bridge program.
That log or lock, Risto? Lock or log?
Lock. Log event. So Solana doesn't have events, they have log. And log can be captured by user-side programs. So that if I set up a log follower to catch some specific things happening at Solana blockchain, I get a notification immediately. So in fact, in our case, the notification arrives even faster than the Solana block gets finalized. So that interestingly, the minted Unicity token cannot be validated even immediately. Okay, but let's check if everything is all right. At the left, we have Unicity. We see that we have a wallet, and we can see the address which we can use specifically for locking the balance. And we have money and we can make transactions. And I copy the address. We need it in a second.
So Risto, how is this different from traditional bridges?
So it's in fact much more lightweight and there are less moving parts involved. First is that it's not necessary to have some kind of like messenger between both of blockchains or contracts within both of the blockchains, because at Unicity side we even do not have to have some kind of trust reference infrastructure running. So in traditional blockchains like from Solana to Ethereum, bridging, it's necessary to have a specific contract or set of contracts at the receiving side, which in effect are implementing a light client within a smart contract, which is a quite heavyweight operations, and so usually some kind of like corners are cut. So we have some kind of like committee sitting in between, and it's not light client, it's just verifying a committee signature or doing some kind of other tricks to make it more lightweight. But in case of Unicity, we do not need this kind of light client at source blockchain, recipient blockchain for validation trust reference, because the validator is in fact a recipient of address of an asset, and he can do whatever necessary. For example, he can contact his RPC node to just check if a block is valid, or he can run his own full light client or full client, and it's like much more efficient because it doesn't have to be on-chain client. It can be like just client as it usually should be. And so the bridge monitor is up, and now I will make a Solana transaction to lock some funds, which generates a log event, which is captured by a program at the left side, which should start minting of a token immediately. Where it was. And the party who can mint a new Unicity token with the same value. I send the transaction. The sender side is trying to verify as well if the transaction is successful and final. We still see that the things start to happen at the left side even before the thing is finalized. Okay, and we have generated quite a lot of information. One is a Unicity token, the most important one. And because the Genesis record is opaque, data structure is not human readable, it's in a JSON form here as well, and some debug information. Just for fun, let's send another one. But I'm stopping the bridge. And let's have a look at the token. We can see that the token data includes cryptographic proof that the locking operation was successful. And this is different on different kinds of blockchains. For example, Solana doesn't have block headers. And there is no such thing as a Merkle tree on top of transactions with a root in block header. So instead, Solana is using transaction signatures. So instead, in order to validate the token, we are just verifying if Solana is agreeing on transaction signatures correctness, and transaction data, like locked up value and asset and everything else, is parsed out from a locking transaction, which is validated based on transaction signature, which is validated based on Solana's RPC. This is rather big, there is some excess of information, and everything else is traditional Unicity token. And as we see, there are no transactions performed with it. And let's have a look what's inside the token as well, or inside of Genesis record. Now, basically, we can see that we have some metadata like nonce, timestamp, recipient, amount, and the transaction which is locking up this information cryptographically.
So this is the actual token.
This is actual Solana transaction, which we are using as a
token.
Yeah, the previous one, what we looked at was the token, but this is part of a token which is parsed so that it's human readable. Technically, we do not need it. This is just in order to demonstrate what's going on.
So this is a more human readable form of the part of the token from the previous file that was this big blob of binary data which you couldn't really look inside, but now it is parsed and explained what is in there.
Was it the transaction data field?
This is a transaction data field, which is basically the Genesis event, which is a justification why the minting is, let's say, secure. And when the token is validated, then this Genesis record has to be validated as well. And we have, in fact, the tool to validate the token. Let's do it right now. And everything's successful. So what happened? We parsed the token. We extracted the locking proof from this transaction data field. We validated if transaction is successful on Solana blockchain using RPC node and based on transaction signature.
So what is the trust model here, Risto? Who do you need to trust when you look at this?
We need, we assume that the recipient of the next transaction next Unicity transaction has access to some kind of Solana node, and he can run this node by himself when the system is completely trustless, or he can trust a friend or some kind of service provider to run the Solana node. So nothing in Unicity have to be trusted.
Cool.
But the Solana side should provide some kind of like RPC, or the user has to run his own RPC.
Very cool.
And let's run the bridge again. I launched 2 tokens, so this one should capture the hanging transaction. Ta-da! Yeah, there is a missed transaction, and so it's the new token is already minted. I'm skipping a validation show, which concludes the demonstration.
Awesome.
Wow. That's really cool.
And yeah, the main difference with other blockchains is the structure of the Genesis record or the token data field. In case of Ethereum, it should be a message generated by a contract and a Merkle tree and a block number, so that using RPC, the block header is fetched, and then the hash chain is validated, and based on hash chain, we can see that the log was generated successfully, and it's validated by all Ethereum validators. So it's a bit more compact and maybe more secure.
Mm-hmm. Cool.
Trustless bridge.
Question.
And it worked kind of immediately. The token was minted even before the Solana achieved finality.
Cool. A quite quick question. So this token ID you derive from transaction ID, right? On the Solana chain.
Yeah, token ID is derived from the chain ID and contract ID, meaning that everybody must agree which kind of contract they trust at Solana side.
Can for instance, if I'm like third-party observer, can I mint this token in front of you? Well, except idea is just to occupy the token ID location, nothing else, just to prevent you from minting.
Yeah. In fact, this is a reason why during the locking transaction, we provided the Unicity side recipient's wallet address. So only the address owner can mint the token, not anybody else.
No, but I can still mint some gibberish token and just hammer the position for you to mint your wallet token, correct? Because if I generate this Unicity proof location, I generate this request ID faster than you and send it to Unicity. I'm going to front run you basically and block you forever from minting this token. Is it correct?
You mean like denial of service?
Yeah.
So you are not authorized to mint the token, or basically you can mint the token, but it's invalid, but still you can issue a transaction.
Yeah, and then you cannot
given current model, there is nothing to do against it.
No, there is. We have exactly the same problem with bridging from Unicity proof of work to the third layer. We can discuss later with you.
Okay.
But it's small fix. It's small fix. We can discuss later how to fix this. I have exactly the same problem.
And yeah, we can see this is a URL for a block explorer. We can see the transaction at Solana side. And this is the parsed contract state after the locking event. Nonce is increased, the locked sum is increased, and escrow balance is the same.
Isn't it the case that Unicity, in order to post a Unicity transaction, you have to you have to provide an authenticator, which is